Dear students, welcome to Edumir Physics. In the last two lectures, we have discussed the production and distribution of electric charges. In this lecture, we will discuss the interaction between the charges. That means the fundamental law of electrostatics, Coulomb's law of electrostatics, its statement, vector form and limitations, comparison between electrostatic force and gravitational force, etc. So let's start from the fundamental law of electrostatics. Fundamental law of electrostatics states that like charges repel and unlike charges attract each other. So if we have two positive charges, then they will repel each other. If we have two negative charges, then they also repel each other. If we have two unlike charges, that means one positive and one negative, then they will attract each other. So if they are attracting or the repelling, a force is acting between them. Okay, this is called the electrostatics force, and the magnitude of this force is given by the Coulomb's law of electrostatics. So let's discuss the Coulomb's law of electrostatics. Let us consider two charges, capital Q and small q, are placed at a separation r. Then Coulomb's law states that the electrostatic force between these two charges is directly proportional to the product between the charges and inversely proportional to the square of the distance between the charges. Therefore, we get F is proportional to QQ by R square, or F is equals to some constant K into QQ by R square. This is the mathematical form of Coulomb's law. Now, in SI system, the constant K is equals to 9 into 10 to the power 9 in air medium, which can be written as 1 by 4 pi epsilon naught, where epsilon naught is the permittivity of free space, which has the value of 8.85 into 10 to the power minus 12 in SI unit. The unit can be derived from this equation. Now in CGS system, K equals to 1. So the Coulomb's law can be written as F equals to 1 by 4 pi epsilon naught QQ by R square in SI system, and F equals to simply QQ by R square in CGS system. So these are the mathematical form of Coulomb's law, and statement can be written from these two. Now let's talk about the vector form of the Coulomb's law. Coulomb's law of electrostatics gives the force between the electric charges, and force is a vector quantity. So the Coulomb's law can be written in the vector form. The magnitude of the force is given by the equation 1, and if these two charges are positive, the small q charge will feel a force in this direction. Let's say it is r cap. We are considering this is r axis, and the unit vector in this direction is r cap. So we have the magnitude of force and the direction of the force. So we can write it in the vector form like this: magnitude into direction. That means k into qq by r square into r cap. So this is the vector form of Coulomb's law. Again, r vector can be written as r into r cap. So r cap can be written as r vector by magnitude of r. Then we can write this equation as F equals to k into qq by r square into r vector by r, or F vector is equals to k qq by r cube into r vector. So this is another equation for the vector form of Coulomb's law. So equation 2 and equation 3 gives the vector form of Coulomb's law of electrostatics. Now what are the limitations of Coulomb's law? The first limitation of Coulomb's law is that it is applicable only for the point charges. If we have a large body, then we have to consider the center of charge of the bodies. The second limitation of Coulomb's law is that it is applicable for the distance between the charges greater than 10 to the power minus 15 meter. That means nuclear diameter. So it is applicable for the distance between the charges are greater than 10 to the power minus 15 meter. That means nuclear diameter. Okay, or 1 Fermi. The third limitation is that Coulomb's law of electrostatics is applicable only for the charges that are the rest with respect to the observer. So charges must be at rest with respect to the observer. So these are the major limitations of Coulomb's law. Coulomb's law is not applicable for the distance less than 10 to the minus 15 meter. Coulomb's law is not applicable for the larger charged object. Coulomb's law is not applicable when the charge is moving with respect to the observer. Now, one of the important properties of Coulomb's law of electrostatics is that the Coulomb's force depends on the medium. Coulomb's force is given by 1 by 4 pi epsilon naught q by r square. Here, the epsilon naught is the medium dependent term, which is called the permittivity. For epsilon naught, it is permittivity in free space, and for any other medium, the Coulomb's law can be written as 1 by 4 pi epsilon naught epsilon q by r square. Here, the epsilon is the permittivity of that medium. Now, what is the relation between epsilon naught and epsilon? This is given by the dielectric constant of the medium. So, dielectric constant of a medium K is given by the ratio of the permittivity of that medium to the permittivity of free space. So the permittivity of a medium can be written as K into epsilon naught. Then this equation can be written as 1 by 4 pi K into epsilon naught q by r square, or 1 by K into q by 4 pi epsilon naught r square. So we can see that for any medium, the amount of electrostatic force becomes 1 by K times, where K is the dielectric constant of this medium. Now K is always greater than 1, therefore the electrostatic force is decreasing whenever we move the system from air medium to another medium. For water, K is equals to around 80. Dielectric constant of water is around 80. So if we move the charge system from air medium to water medium, then force in the water medium will be 1 by 80 q by 4 pi epsilon naught r square. That means force in water medium will be 1 by 80 force in air medium. So it is decreasing by a factor of 1 by 80. Now let's talk about the comparison between Coulomb's electrostatic force and Newton's gravitational force. The Coulomb's electrostatic force between two charges is given by F equals to something constant K q by r square, and Newton's gravitational force between two point masses is given by F equals to some constant G, gravitational constant, m by r square. Now these two forces have similar kind of equations, and there is a comparison between the forces. That means there are some similarities between the electrostatic force and gravitational force, and there are some differences between these two forces. So first discuss the similarities between the forces. Similarities between these two forces. So first similarity is that both the forces obeys the inverse square law of the distance between the charges or the masses. And the second similarity is that both the forces are conservative forces. Both the forces are conservative forces. That means we can recover the work done by these forces. That means in the forward direction and the reverse direction, the work done by these forces are the equal and opposite. So these are the two important similarities between these two forces. And now let's talk about the differences between the gravitational force and electrostatic force. So first major difference is that the electrostatic force can either be attractive or repulsive. Two like charges repel each other and unlike charges attract each other. That means this force can be attractive or repulsive. But two masses always attract each other. So gravitational force is always attractive force. So electrostatic force can be attractive or repulsive. But the gravitational force is always attractive. The second major difference is that the electrostatic force depends on the medium because it consists of a medium dependent term called permittivity. But the gravitational force is independent of the medium because the constant is the universal gravitational constant. So it depends on the medium and gravitational force is independent of medium. So these are the two major similarities and two major differences between the electrostatic force and gravitational force. And this is all from this video. In the next video, we will discuss the electric field intensity and electric field lines. If you find this video helpful, please like it and subscribe this channel to get more videos related to your board exams. Thank you.